help you out with your circle and area practice, I'm going to pretty much focus on the left side, which are our problems. I will kind of get you started. But anything I do, you're going to do on the even. So here is the worksheet that you need to do for homework. And I did 1 and 2 as an exit, but just to recap, because if you have a highlighter or some map pencils at home, this color coding might help you see the relationship a whole lot better. So since angle X, or X is this angle here, and that angle is formed basically by these two chords intersecting. So I need to know the intercepted arc is between them. And I'm going to do that a different color. That's this. Oops, I keep picking yellow, sorry. Yeah, so that's this curve, which is a 65, and this curve in between the other yellow side, which is 144. So to get the X, the interior angle, the interior angle is always half the sum. Okay, half the sum of your arcs. So I'm just gonna go ahead and see X is 1/2. We're gonna do 65 plus the 141. PEMDAS, if you want to, if you should do, sorry. So that would end up being 1/2 of 206. And so that means our X is 103 degrees. We're gonna box our final answer. So you have to do that same thing on number 2. Most of y'all had set that up and saw that X would be 1/2 of 43 plus 33. But you do need to get an answer, because that's what I'm going to be checking for. This whole thing is completed. Now, when we get to number 3, X is the vertex right here. We're talking about that angle. That vertex is on the circle. So, and again, we're creating that angle. Excuse me, let me scroll up here a little bit. We're creating that angle using this chord and this tangent. So I need to see that intercepted arc. That is from the end of the chord, that curve all the way to that vertex. So since it's an inscribed angle, if you need the little, notes, the little review, your inscribed angle is always half the intercepted arc. Running out of room, but gotta bear with me. So that means to get to my X, I'm doing half my green arc, which was the 200. So that means exactly X is 100 degrees. Good job. So you kind of got a multi-step on number 4, because on 4, the 47 is the angle. Okay. So what you have to do is find this missing arc. Kind of work backwards. So the 47 is the angle. So the 147, excuse me, equals half of what arc, what number do I have to get that 147? I'll work backwards, multiply. And then once you know that, to get to a full circle, so if I was coming all the way around to get to this arc here, and I need to do that a different color, to get this arc right here, I'm using a full circle, which is 360. So we'll do 360 minus, and let's change that variable that we had before. I know I said X here. Let's make that a Y so you don't confuse you on what you're trying to find. So 360 minus Y will give you your X. So you do have to figure that part out. I didn't do that for you. And so using my hints, using my setup to get you to finish. But 5 and 6 go together. So I'm hoping you recognize on number 5 what type of angle do you have. If you have your pink notes, that would help you break it down, go down the flow chart. But I'm hoping we see that this is what we call an exterior angle. And when it's outside the circle, we subtract. When it's inside, exactly, you add. So we're going to do the same thing we did before. We recognize, I don't know why it keeps doing that part. I'm going to figure out how to fix that. So here is what's creating the angle, the two secants. Here is the core, the arcs, okay? So when it's outside, we subtract, but we still take half the difference. So if its exterior angle is half the difference between the arcs. So That means x is 1/2 the 72 minus 22. Start with the big arc and then subtract it from the smaller arc. PEMDAS does that we do what's in parentheses, 1/2 of 50, which gives me that x equals exactly 25. So you're going to do the same thing on number 6. Just so you make sure you see, there we have a secant and a tangent, and our chords are this big chord at 120 and that small chord at 32. So make sure you're doing that for number 6. And number 7, multi-step. Find x and y. So y or x is outside, so that's an exterior angle. So that's when we're doing the same thing we did on 5 and 6. But y represents an arc, and it's just this little piece right there. But I'm hoping you see this part of the circle. That is the diameter, exactly. What does it do? It cuts the circle in half, so each half would have to equal what? Exactly 180. So that means that if I know already 55 and 100 right here, so that's 155. So to get to y, I just do 180 minus 155. So y, that piece of arc, that piece of curve that remains, is our 25. So to get to my x, that's when I'm using that exterior angle again. So I have to use the intercepted arcs here. We already have this whole arc here, which we know is 180, and this arc in between the two secants. So basically, to get to my x, I'm doing 1/2 of 180 minus 60. PEMDAS tells me to do that with some parentheses first. So I get 120, a half of 120. Yep, and 60 degrees. So there is my x. Now, to get your x, y, and z, you got to do a couple things here. Find your x. Just give you a little clue. Your x, okay, is using these two chords. So the intercepted arc is right here. And I can get that arc by using the 60, because the arc is, this is the intercepted inscribed angle right here. So this 60, the arc has to be double that, so that's 120, which we know would have to be the same thing and related to x. That's the same value, but we're going to use half of that to get to x. And then, because I know that that is 120, and I now know that this is 60, I can get my z here using a triangle equals 180. And then, once I get that angle, the arc that goes with z is right here. And that will help me to get to my y. So it's a little multi-step. Try to see if you can do some problem solving and work it out. Test yourself, challenge yourself, take a risk. You got this. All right. Now, when we get to the back, that's our area. So on number 9, find the perimeter, apothem, and area. This is what we were doing with our yellow notes for some of y'all. And a couple things you need to get in the habit of doing. Drawing your center, drawing your radius. So here's the radius from the center to the vertice, from the center to the vertice. I know it's a little crooked, but we have 2 radii. Then, I'm going to fix that a little bit, sorry. Then you also want to draw your apothem. Your apothem goes from the center to the side, and every time that happens, it bisects that side. Well, since we know the side is 10, that means each little piece here is 5. The other thing we need to get in the habit of doing is finding the central angle. The central angle will help me get to my apothem, or, I spelled that wrong, or it will help me get to my radius. So your central angle is always 360 divided by the number of sides. So we know we have a hexagon here. So basically we have our 360 divided by 6, which is 60 degrees. But at our central angle, the apothem bisects it. So we always take half of that 60 to get our vertex angle over the right triangle. So that's the 30. So there is the 30. Okay? I know that kind of looks bad. But get in the habit of creating your two radii, your opossum, and your right triangles, and finding your central angle and your missing angles. So now I can do my perimeter, because my perimeter is just adding up the sides. And since I have the sides, the 6 times s, which is our numbers, our value for our sides, so 6 times 10. So we know that perimeter is 60. Easy peasy. All right, so we got that down. But to get to the opossum, which is right here, I have to use that special, right, that 30, 60, 90, because the 5 is opposite to 30, which would be the short leg. So to get to the hypotenuse, I will double the short leg, which means it's 10. And to get to the opossum in this problem is basically the short leg times radical 3, which would be 5 root 3. So now I can substitute it in and get that area. 1 half opossum times perimeter. So 1 half times that 5 root 3 times the 60. Well, the numbers I can multiply together are the 5 and the 60, but then I have to take half of that. Okay, so then I have to take half of them. So that ends up becoming 150 root 3 units squared. That's our answer. So once you try number 10, because it's very similar to number 9, but there's one little piece that might change just a little bit, or maybe it didn't. So see if you can go through the steps. On 11 and 12, because you're doing the area of a kite, the area of the kite is 1 half diagonal 1 times diagonal 2. Okay, there's two different diagonals. All right, what we have here is B to D. B to D is right here. That's one of your diagonals. It's 15. So there's one diagonal. And from across the other vertex, A to C, that is our other diagonal. That's diagonal 2. So now I'm just going to plug it in, substitute the parts. So this would be 1 half of my diagonal 1, which was the 15, times my diagonal 2, which was 10. So half of our 150 is going to be 75 yards squared. That is the area. Box that final answer. And then 13, area of a triangle. Here we're doing 1 half base times height. Well, what part represents our base? Exactly, 30. That's our base. That's our B. What part represents the height? Good job. 12. That's our height right there. Just from the base to the vertex, and it's always perpendicular. I know they forgot that box, but it's perpendicular. So we're just plugging it in. 1 half base, which is 30, times the height, which is 12. And we get 180 feet squared. Alright, so you're going to be responsible for number 14 and for the ones I didn't do. And we will be checking this tomorrow. Thank you for taking care of this. If you need help, come see me in tutorials. Thanks.